Two functions can be combined together arithmetically through addition, subtraction, multiplication, and division. The arithmetic combination is relatively simple, so I will explain simply using examples. For example, here are two functions, fx equals to 2x plus 1 and gx equals to x squared minus 3. Notice that both these two functions have domains of all real numbers. Now, the sum of these two functions is denoted as f plus gx and is defined simply as fx plus gx. Therefore, for this example, that equals to 2x plus 1 plus x squared minus 3, and that is x squared plus 2x minus 2. And as you can probably guess, this is exactly the same as the sum of gx and fx, g plus fx. If we want to find out the sum function value, for example, at x equals to 2, we can use this combined function that we already derived, x squared plus 2x minus 2, and just substitute in x equals to 2 and evaluate, and that is 6. But also, we can simply evaluate the original fx function and gx function individually at x equals to 2. So, f function evaluated at x equals to 2 equals to 5. And then g2 equals to 2 squared minus 3, and that's 1. Therefore, the sum function evaluated at x equals to 2 simply equals to f2 plus g2, and that equals to 6. And as you can see, you get the same answer. The difference of the two functions, denoted as f minus gx, simply defined as fx minus gx. In this example, that is 2x plus 1 minus, within the parentheses, x squared minus 3, and that equals to negative x squared plus 2x plus 4. And in this case, this is not the same as g minus fx, but instead is negative g minus fx. And the evaluation follows a similar rule as we described earlier. And similarly, the product of the two functions, denoted by f times gx, defined as fx multiplied by gx, in this case 2x plus 1 multiplied by x squared minus 3, that equals to 2x to the third power plus x squared minus 6x minus 3. And this also is the same as g times fx. The evaluation follows the same rule. And lastly, the quotient of these two functions is denoted as f over gx, that equals to fx divided by gx, in this case 2x plus 1 divided by x squared minus 3, and obviously that's not the same as g over fx. One more thing I want to remind you. Remember earlier I mentioned that for both of these two original functions, they have domains that include all real numbers, and for their sum, difference, and product function, there is no additional domain restriction. However, here we have a quotient format, and we know that the denominator cannot be 0. Therefore, for this quotient function, the domain is x squared minus 3 cannot be 0, and x cannot be plus or minus square root of 3.